So just a bit on the title of the talk. Barbara Liskov said that programming languages are about computational power, and not so much about, no, rather, sorry, what did I say? They're not about computational power, they're about expressive power. So this is where the title comes from. So it's for an audience that's familiar with Erlang and Elixir and OTP. And so, yeah, I guess Peter asked this in the last talk, but how many of us have an Erlang background? Okay, so I guess that's a good half of us. And then how many of us sort of identify with an Elixir background? Yeah, so it's almost an even split, which is nice. So I started with Erlang, and I've been doing Elixir for about 2 years now. Right, so this is intentionally blank because I want to start with a quote. It's from an architecture book, 101 Things I Learned in Architecture School by Matthew Frederick. And the quote goes, "A good building reveals different things about itself when viewed from different distances, and so should a good program." And I hope we're going to come to see this sort of throughout the presentation. Right. So we're going to start with the source tree, which I feel is sort of as far or as distant as we can, as much as we can distance ourselves from the source itself. So this is POX. POX is an HTTP client. Ignore the name if you're a native English speaker and you know what that means. But it's an HTTP client, and what I want to highlight here is that we can see from the directory listing, right, that there's a wire format, there's a request, and there's a response, and that the wire format consists of a body, a header, and a status line, and that actually the directory tree communicates all of that for us, right? So we're standing as far back as we can, sort of conceptually, and we can see, we can glean all of this information just from the directory tree. So in colloquial English, we might say, we can see the forest for the trees, right? So that kind of explains the picture here. And again, another quote from Barbara Liskov, right? I think it's her at least. It might be Rob Pike. Kind of went through a bunch of videos trying to find out who said this. But basically, it goes something like this. If we get the structure right, then everything else falls out of that structure. And there's nothing that represents or that sort of communicates structure like a good directory tree, I think. And of course, on bigger projects, this matters a lot, right? I've seen it work out for us in practice. We're able to flesh out that structure, sort of get that across in a directory tree, and it really pays off big time down the line because engineers coming to the project, they know right away where they have to go to make a change, where they have to go to introduce some new functionality. And if we think about this, this all sort of boils down to the idea of a module, the directory tree, the naming conventions, all of these things that we have in Elixir. So while we're on this topic, I want to talk about the kind of tree correspondence we have between the directory tree and the supervision tree. So this is really about concurrency, right? And it's not about primitives. It's much more about, like I said, OTP. So that's things like the application, the supervisor, and the worker. So we have those there. Of course, we have other behaviors as well, like the stage, generic behaviors. We have the agent and the task. But I think a while ago, I was discussing with a colleague about what declarative programming means to us, right? And I sort of explained what it meant for me, which I still sort of go by. But I thought his insight was great, and that was that this correspondence really sort of spells everything out for us. It spells out all the concurrency that's involved in our system, and his sort of view on declarative programming was the idea that you can take a look at the directory tree and you can get all this information about how concurrency is structured in our servers, in our programs. And so that was the insight there for me. And so this is sort of why I advocate the use of the module supervisor, which we're sort of being more forceful with in the Elixir release, recent Elixir releases. So the idea there again is that it really spells out just from the directory listing exactly what your supervision structure is like. And then the other one is the dynamic supervisor, which is a recent addition, and that really fleshes out another behavior that we haven't had in quite the same way with Erlang and OTP. And so the construct that sort of ties these two things together, the directory tree and the supervision tree, is the module, and that's what we'll look at next. So okay, let's stick on that side for a bit. So so we have the application, the supervisor and the worker, which we're all familiar with, and of course we have the client here at the bottom, which really is meant to give us that interface that we want, probably to talk or communicate with the worker. So our top-level API resides in the client.ex, and we have sort of operational concerns with regard to concurrency, really spelled out for us in the directory tree, in those modules. Okay, so back to the module. The reason why it's a sort of a bookcase or a picture from a library is because the module is really our construct for organizing things, right? And so we do that by grouping things and by naming them. And so I guess I'll tell another story here. I guess this was maybe a couple of months ago. There was a question in the Elixir forum about our favorite language features in Elixir, and I knew right away, without a doubt, what it was for me, and it was the module. And I also kind of correctly assumed or predicted what it was for other people too. And so they said things like concurrency and the things Elixir is big for. So what else is there? Pattern matching. But it had to be the module for me, and the reason why is because if we take the module, it's the construct that lets us capture vocabulary, right? When we have a domain, when we're working with something, when we're building something for a domain, whatever it is that we're doing, the module is a construct that really lets us communicate that vocabulary that we should be capturing, right? The verbs and the nouns. So if we think about POX again, the HTTP client, we had a request there, we had a response, and we had the wire format. So those are sort of the nouns and the verbs there. Or rather, maybe the verbs are better captured here. So we have the get and the put, and of course, the HTTP vocabulary is something that we're really familiar with, right? HTTP really fleshes out what it means to sort of work with data when it resides on a remote server. So what else is there? So I think we have a tendency to sort of really spell things out in functional programming languages, right? Or maybe it's just the Erlang and Elixir community. So we end up with sort of five-word function names. How many of us have seen those? Yeah, really only. How many of us have seen five-word function names? Okay, okay, so a few more, right? When you ask a second time. So, and then you have like three-word variable names as well, right? So this is sort of a verbosity that we really don't want, right? So Pike and Kernighan said in the practice of programming that brevity is not clarity. So I think that's very true. But verbosity isn't clarity either, right? And so what we see, I think, often is a sort of common prefix or a common suffix in a lot of our function names. And that probably suggests that actually we should be moving a lot of that logic, fleshing out things like data and functions into a module. And that goes for all sorts of things, right? This is for both operational and functional concerns. We should really be moving some of that stuff if we have common prefixes and common suffixes into a module. So I really wanted to get a factory for this part, for this picture. And the reason is because the factory has inputs, it consumes inputs, and it produces outputs, right? But I kind of settled for what looks like a nuclear power plant, just because the side effects are important there, right? So we kind of talk about the process as being our main mechanism for isolation, right? But I'd say that actually our first line of isolation, success or failure, that it should really be the function. So here's POX again. So this is the part of POX that reads a status line from an HTTP request. So the first line here basically splits things up into what should be a protocol sort of fragment, a number, and the text for the status. And then on this line, we're asserting that it's HTTP1 because this is all we're dealing with. On this line, we're making sure that we recognize the status number that comes in and that it matches the text that we get. And then the only thing that the status line really returns at the end is the status number itself. And so if we kind of test that out and give it something like HTTP 1.0 instead of the 1.1 that we really expect, this is how it sort of, this is the error message we get. And we can see so clearly, right, that it's because we're pattern matching on the HTTP 1.1 there, and that's not succeeding. And so where I'm going with this is that, really sort of being exhaustive here, the idea of intentional programming, as the airline community likes to call it, I think, and maybe it's assertive programming for the Elixir community. This idea of really being exhaustive in terms of the fact that I'm only dealing with HTTP 1.1. I expect a certain number of statuses or status numbers and corresponding text that I'm working with. Really sort of being exhaustive in that regard is sort of about isolation, right? This is what it means when something fails. I can look up line 8 and I know right away where something is going wrong. And so there's nothing like being called up by a client, right? And they kind of tell you that, there's something wrong, and you have some idea of what it is that they're doing wrong, maybe. Most of the time, in my experience, at least. And so you ask them, are you doing this and that? And they say yes, and okay, so you say you'll have a look. You go and you have a look at your log files, and you get something like that. You dig into the code, and you know straight away what's going wrong. And so you can tell them, look, I see this crystal clear, right? Because I did this thing where I literally spelled out absolutely every single thing that I was doing here. I was really exhaustive, and I can see now that actually you're not sending me these 2 or 3 things or whatever it is that you should be. Right. Okay, so I guess this is really the heart of the talk, and it's this sort of idea about a functional kernel and an operational shell. And what I'm getting at here is actually the tremendous value that it can mean for our organizations, right? There's a reason why we build stuff. And whatever it is that we're building should be sort of captured in a functional kernel, right? Our domain, that's all sort of, we can model that with pure functions all the way, and then all the operational concerns should really wrap that around. And so that's the idea here, and I want to sort of list or give you some of the reasons why we should really sort of pursue this distinction, and why it has so much value. And so the first thing is that it's flexible. If we have our functional kernel, so whatever business logic that might be, we can wrap whatever operational shell we want around it. So it could be an HTTP server, right? It could be a queue, but whatever our interface is, we can wrap that functional kernel around in it. So I guess a couple of times I've heard this idea that if we sort of switch to some kind of a synchronous architecture, then it's going to make our business logic a whole lot easier. And that can't be true, right? Because that doesn't make any sense. Your business logic is very separate, very distinct from the operational. So if you really concentrate on this distinction, right, getting the functional kernel there that we want, that pure model, and then wrapping that around in an operational shell, and that could be an HTTP server, that could be just something behind a RabbitMQ client, then we can switch the operational around, and everything works beautifully. So this is about flexibility. The other advantage is extensibility, and so flexibility and extensibility, they're different things, right? Flexibility is about taking what we have, maybe repackaging it. That's flexibility. Extensibility is about if we need to make a change, add a feature or change a feature or something like that, then all we have to do is sort of go into the code, do that, and importantly, we don't need to do as much work around just to introduce a feature or indeed fix a bug or refactor, right? So there's none of that. if we get it right. And so that's the idea of extensibility. So a lot of that really hinges on getting it right, which isn't so much what this talk is about. But it's also sort of, if we make this distinction again between the functional and the operational, it can be really illuminating. How many of us use a logging facility like Sentry or Graylog or one of these things? Yeah. Okay, probably more of us than put their hands up, right? Either way, we probably use logging to some extent. And so if we have these distinctions, right, we know when our business logic goes wrong, because that's all captured in the functional kernel, which we sort of made very exhaustive, like we saw with the POX example. And occasionally when the operational goes wrong, writing to a socket or whatever it might be, we get really clear error messages, right, in our logging systems, and they can really help in those situations. So how many of us use dashboards? Okay, so I think there are probably two distinctions again. Guess what? It's the functional and the operational, right? So our business logic resides within in the functional sort of domain. And so you have one dashboard, right? If you do business intelligence and things like that, then the functional kernel, to a large extent, contains everything you want to get into your business intelligence metrics. And so all you really need to do, because you've fleshed out all of this, fleshed out your domain, is just stick a sampling procedure inside a function, right? So it's really simple. And of course, if we're measuring things like request and response times, then that's really clear-cut as well, because we just need to put a sampling function in the right place again. So I used to think this was an art, right? I used to think that deciding where to put that sampling function before or after something has happened, I used to think that there's an art to that, right? But I realized very quickly that actually the art is in just constructing or making a distinction between these two things. Right. And then one thing that's sort of become apparent to me recently as well is the idea that actually when we've done this, it's really easy to configure software as well, just because the parameters sort of naturally fall out of whatever it is that we've built. Right. So, Maya, do you know how much time I have left?
It's about 5 minutes late, right?
Yeah. I think it's about 20, isn't it?
Yeah.
Okay. Right. Okay, so on to the expression next. And I definitely feel like this picture doesn't really express what I want, but expressions are really about value, right? Or about values, and the idea that every construct in Elixir, so you can see I'm talking about Elixir a lot, or the idea that every construct, including our control constructs, have a value once they're evaluated. So sort of in the microscopic sense, it just means that that we're sort of removing a lot of the rote of working through collections. So I think a good model for sequential Elixir is the idea that it's actually structured programming minus the looping constructs plus functions as values. And so if we really think about that, it's sort of, when we come to functional programming, we're sort of introduced to inductive data structures, right, like the list, and they're sort of intimately tied together with recursive functions. And so what we do very quickly is remove the operational concerns from that, so things like the base case and the inductive case, and we sort of graduate to list combinators and higher order functions. And we do all of that with the purpose to really focus on the data itself and on the transformations, and not so much the work of actually working through them and going through them. So it's the idea that the collection is more important, right, than the rote of going through it. So in the macroscopic sense, because this is just what I talked about, was very sort of small scale, right? How does it help us build bigger software projects? Well, it gives data center stage, right? So it's the idea that it's about data flow and it's not about control flow. Yeah. So we have a sort of small digression now into notation. Um, and who loves the pipe in Elixir? Yeah, me too. And I hate it when it's misused as well, right? um, okay, so if we have an expression like that, I hope most of us can see that. But basically, it's a mathematical formula. I don't remember right now what it does. Oh yeah, I remember now. Okay, it comes from TPK. So if any of us know that problem, this is what that is. But basically, it's a mathematical formula. And the idea here is that really, when you have operators and there's no clear subject to whatever computation or whatever expression we have in front of us, then this sort of notation really lends itself well to this problem, right? So again, that's because there's no clear subject in this case, and because operators like the operators and rules of precedence, really help us understand this more than a pipe. But when we have something like this, I guess we all know it's obvious that that a pipe works well for us here. So that's what we have on the next slide. And the important thing is that obviously there's a clear subject here, the collection, and the successive transformations we want to make on that collection. And so in this case, the pipe really aids readability and it doesn't hinder it. And if we sort of dig into the idea of referential transparency, then this is what we have here, right? We start off with a collection, and we're able to actually sort of think about things as data flow. We can replace those procedures with the data. And if we go back to this example, which is the formula, again, this sort of notation really lends itself well, I think, to other expressions, things that might involve socket I/O, for example, maybe occasionally. All right, so we've talked a lot about sort of source code, right? And we haven't talked much about its companion, the test. So I think it sort of, like a lot of software, comes down to philosophy. And for me, well, my philosophy at least, comes in two pieces. So that's what I'd like to share. And those two pieces are the idea that our test cases should be distinct and that they should be explicit. So let's have a look at what that means. So we have the absolute function here. I think a lot of the difficulty in choosing examples for talks is that you kind of face this trade-off where you have something really simple, right, so that everyone can understand, and you can really get your point across, and then the sort of triviality of it as well. But anyway, so we have the absolute function, and I guess we all know what that does. But what I want to sort of get across here is that there are three distinct cases, right, that we want to be explicit about. There you go, I used the word explicit when I didn't mean to. Okay, but there are three distinct cases. So we have the positive case, the zero case, of course, and the negative case. And so this is the idea of being distinct. If we do something wrong or if we break something in the implementation, then hopefully one or more of those will fail, but we'll be able to sort of pin down which one, right? This is the idea with the distinct. Okay, so if we look at being explicit, this is some real code that we had. So what it does is take a data structure, encode it, and then we want to make sure that it's the right number of bytes long. So we did the paperwork or the math on some paper, and we put the 76 there. But looking at that a couple of months later, you don't want to be doing the paperwork again, right? Or you have no idea where that came from. It really doesn't tell me much, just that it should be that long. So this is something that we really did. We sort of broke that up and just spelled out the computation or the calculation we did on paper. And so this is a lot easier to sort of read, of course. It goes back to this idea of being very explicit. So now we can tell that actually it consists of a header, a body, and a tail, and and that those constituents have their various lengths. So obviously this makes it easier to change, easier to understand, and easier to correct if something goes wrong. So this is the implementation of the total function, which we have on the previous slide over here, and of course that's super short, right? Really easy. And I think, so the reason why I have the WYSIWYG there is because if we look at that, there are a couple of things at play here, right? We have atoms, we have keyword lists, tuples, whatever, and the idea here is that this is all really very symbolic, right? This is hard to do in a lot of languages, but really quite easy to do in Elixir. And the implementation for that total function is super simple, which is really nice. I think this is one of the sort of big attractions of functional programming. Okay, so this is a property-based test, and I have it here just because sometimes they express intent, I feel, a lot better than a sort of traditional test would. And it almost becomes irrelevant with the title, right, or the text. Absolute one is positive regardless of the input's parity. But you can see that because the test case itself almost spells that out. So I think that's the way forward for some pieces of logic. Right. And I have a summary for you. So we sort of looked at the source tree, and we kind of saw how actually it can communicate a whole lot, about our projects. And then we took that and moved on to the sort of tree correspondence that we see between the directory tree and a supervision tree, and how that really spells out the concurrency that we've sort of put together. And so I think, apart from Akka, there's really nothing else out there that spells out concurrency like that, right? I guess concurrency is the operational concern out of all the operational concerns. That's probably really hard to capture in a declarative way, and OTP does that with the directory tree. Cool. So we saw how the module was the sort of construct that really tied those together, and then we moved on to the function and how that's really probably should be our first line of isolation as opposed to something like the process. And the way we get there is to really make things exhaustive. And then we sort of went on to the idea of the functional kernel and the operational shell, and really sort of drawing that division there. And then we looked at the expression. And the idea, the big takeaway there was that our project should really be about sort of this idea of data flow as opposed to control flow. We took a brief digression into notation, which isn't listed there, is it? Oh dear. Okay, but we looked at notation and really, the right place or the time and place to use a pipe, and then we finished with testing, right, and some principles there. So I think a lot of this is stuff we all already know, right? And we have at least some familiarity with, but really sort of pursuing these in bigger projects, especially from the beginning, I think is a challenge. So I want to leave you with a parting thought, and that thought is that adopting Elixir is about adopting a declarative. Isn't about adopting a declarative language. It's about adopting a declarative mindset, right? So I hope this is sort of useful for engineers. This is sort of code that we wanna read, but obviously we have to write if we're gonna read it. For technical leads, I think this is the sort of thing we want to champion day in and day out. If you're an architect, then maybe this is the sort of material that you wanna know, so that you have sort of informed architectural decisions or design decisions. And for CTOs, CEOs, CIOs, directors, vice presidents of engineering, I hope this convinces you to talk to our salespeople outside. Yeah, so I have a few thank yous. I think first and foremost, my colleagues, former and current. Like I said, I'm at Erlang Solutions. We're a consultancy. We do resourcing and training on Elixir and Erlang. And I also want to thank the extended community. So So this was the functional programming community, but really, really it's the Elixir community, the Erlang community, the functional programming community, and even beyond that. So there's a lot of good material online that I've read over the past few years that has really sort of made its way into the talk. So I'm Joseph Yiasemides. You can find me on GitHub as DZOL, and I hope there was something here for all of us. Thanks.